Low-frequency radiation and altered consciousness. This DC system contains ELF oscillations that seem to be associated with information flow, and its operations are sensitive to external low frequencies. The overall level of consciousness is regulated by DC current flow in the primitive midline structures in the brain. Loss of consciousness can be produced by nulling out or reversing this flow with properly applied DC currents or strong, steady magnetic fields. There appears to be a roughly linear relationship between the extent of consciousness loss, as judged by the EEG pattern, and the amount of electrical current applied. In the 1960s, I studied the effect of consciousness of the addition of various ELF frequencies to a baseline DC current. I found that for any current level, a great loss of consciousness could be produced if I added a very low strength 1 Hz frequency on top of the DC current. The 1 Hz frequency alone had no effect on consciousness, and the same strength of DC current produced much less loss of consciousness. Together, the two produced a greater effect. I later found that any frequency between 1 and 10 Hz had about the same effect. About 10 Hz, however, the enhancement decreased linearly and with the rise in frequency until between 20 and 30 Hz, the effect was no better than with the DC current alone. This experiment produced two significant conclusions. First, the DC electrical system in the brain that is related to consciousness is sensitive to very low levels of ELF. Second, only the ELF frequency range that makes up the naturally occurring micropulsations is effective. The concept of dual nervous system with a primitive DC analog system and superimposed sophisticated digital nerve impulse system is strengthened by the observation of these ELF effects. The DC analog system is influenced by ELF fields. In fact, the interception of natural ELF fields appears to be one of its functions. The capacity of ELF fields to alter consciousness and behavior indicates that the interface between the analog and digital systems may be involved in some of the higher nervous functions that we have difficulty explaining with the hardwired model. If the digital nervous system, by which we see, hear, smell, and taste, and feel, and move, is the child of a more primitive system by which we grow, heal, and obey the physical rhythms of our world, then there must be an intersection, a meeting place between the two. Is this the home of the mind, the site of memory, logic, and creativity? Earlier in this book, we saw how we can consciously cross over this interface and gain access to our own DC systems in order to heal ourselves. By the same mechanism, we may gain control over our thought processes and behavior as well. However, it appears certain that ELF electromagnetic fields, both natural and man-made, can access the same interface and produce significant changes in the total operation of the brain. The duality of mind and brain has been a philosophical challenge to science for centuries. The dual nervous system and brain described in this book can provide us with a new way to view the age-old challenge. The implications of this work are considerable. It would seem that we may not be the free agents we like to think we are. Our thoughts and actions are, at least to some extent, determined by electromagnetic fields in the environment that we cannot sense and that we cannot remain unaware to our peril. The darker side of the problem, the ability to control the human mind, now assumes far greater importance than when Jose Delgado first proposed this possibility in 1969. The political and military implications cannot be and apparently have not been ignored. In the next chapter, we will explore the complex interaction between the inner and outer fields. Chapter 10, Linking Up Inner and Outer Fields, Mechanisms of Action. Science is a hard taskmaster, and in the light of mounting evidence that suggests of toxicity, are for the most part ultimately confirmed by painstaking scientific inquiry. Perhaps it is time to re-examine whether scientific standards of proof of causality and waiting for the bodies to fall ought not to give way to more preventative health policies that are satisfied by more realistic conventions and that lead to action sooner. Editorial, New England Journal of Medicine, April 1987. We have seen how living things have been tied to Earth's natural magnetic field from the time that life began. We have seen too how each individual cell, as well as entire organisms, senses and derives timings information from the natural cycles of the geomagnetic field. And we have also seen how human use of electromagnetism for power and communications has produced an abnormal electromagnetic environment unlike anything that existed before. While the evidence that these abnormal fields have major biological effects is now overwhelming, classical physicists now know of no mechanism whereby either normal or abnormal electromagnetic fields can have any biological effects. This has been the major reason why there has been great reluctance on the part of physicists and engineers to accept the biological and medical data as valid. Yet the data currently available are as conclusive as the data relating cigarette smoking and lung cancer. Our knowledge of the latter link is based solely on epidemiological studies. In the area of non-ionizing electromagnetic fields, we have both epidemiological and laboratory studies indicating that abnormal frequencies produce increased health risk. However, no effective action has been taken ostensibly because no mechanism of action has been identified. The governmental agencies that are responsible have discounted the reports of bioeffects because it is thought that these simply cannot be true. Scientific standards of proof of causality have been stringently applied. Part of the problem is that the evaluations of the biological and medical data have been in the hands of engineers whose knowledge of biology appears to be minimal at best. For purposes of developing a mechanism of action, they viewed the living organism as identical to the dead organism, or worse yet, to a water-filled copper sphere. As a result, neither subtle changes in biological functions nor distinctions between effects at the cellular level were ever considered. In this chapter, we will consider a groundbreaking theory that explains how both single cells and whole organisms might gain information from electromagnetic fields. This chapter is more technical than the others. You may consider it optional if you find it too difficult. However, the information presented here is the key to unlocking many remaining mysteries, such as cell division, the healer phenomenon, and extrasensory perception, ionizing radiation, non-ionizing radiation, and heat. When we first began to make use of electromagnetic energy, it was already known that the entire electromagnetic spectrum could be divided into two parts. Frequencies below those of visible light lacked the power to produce ionization of the body's chemical structures, and those higher in frequency than visible light contained sufficient energy to do so. Ionization is the disruption of an atom or molecule by strong electromagnetic energy, causing the ejection of electrons from the material. The resultant atom or molecule is electrically imbalanced and has not a net electric charge. In this state, it is called ionized. Such ionized molecules are chemically very active and produce abnormal chemical reactions that are damaging to cells. From a physical point of view, it's easy to understand how ionizing radiation can cause bioeffects. By the same token, however, because non-ionizing radiation lacks this ability, it was believed that it had no possible bioeffect except the gross production of shock or heat. In the early 1900s, our technology was limited to the very low frequency range of the electromagnetic spectrum. Radio, for example, operated at few thousand hertz. As our technology advanced and we began to produce higher and higher frequencies for radio transmissions, it was accidentally discovered that frequencies of about 27 million cycles, or 27 megahertz, and higher could be generated with sufficient power to produce heating of human tissues. This led to the theory that the energy content of any electromagnetic radiation was proportional to its frequency. The higher the frequency, the greater the energy content, and vice versa. For practical purposes, the dividing line for the production of heat by this radiation was set to 27 megahertz. Therefore, frequencies above 27 megahertz would produce proportionally more and more heating effects, while those below 27 megahertz had less and less ability to do so. This was taken to indicate that any biological effect that was not the result of ionization had to be the result of heat. The antenna theory and heat effects. The antenna theory, the first attempt to explain non-thermal effects, was mentioned briefly earlier in this book. Actually, this theory still explained non-thermal effects as heating effects by postulating the maximum transfer of energy from the radiation to the human body by frequencies whose wavelengths equaled the dimensions of the body. In that way, a field strength below the thermal level was supposed to cause body heating. There are, of course, problems with this idea. For one thing, we don't spend all of our time lying down. Nevertheless, the EPA became very interested in this concept because the 100 megahertz frequency is centered within the 88 to 108 megahertz band assigned to commercial FM stations, which are common in the environment. However, it was soon pointed out that unless the person is very close to the FM transmitter and received adequate power from the signal, tissue heating could not occur even if a resonance situation was produced. Heat is molecular motion. The faster the motion, the more heat there is. The molecules of every material object are in constant motion, with the rapidity dependent upon the ambient environmental temperature. This motion stops only at absolute zero, far below 0 Fahrenheit. The molecules of the body are therefore continuously in motion proportional to the body temperature. This is called KT, or kinetic temperature. In order for heat to have any biological effect, enough energy has to be transferred to make the molecules move even faster. The energy in the environmental FM radiation was simply not enough to produce perceptibility more molecular motion than that of KT, and it therefore could not increase body temperature at all, even if the person was lying down. According to this concept, microwaves produce their heating effect by causing oscillations of body molecules that are of a size to be resonant with the wavelength of applied microwave radiation. Unfortunately, this is not the case. Microwave heating is actually produced by an increase in the motion of water molecules. This poses a real problem for the theorist. The size of the water molecule is far too small to be resonant with microwaves. In fact, water is optimally heated by infrared radiation, which has much shorter wavelengths than microwaves. At this time, we really do not know exactly how microwaves produce their heating effect, even in the ubiquitous microwave ovens. A number of theories have been proposed, and the interested reader is referred to a review of this problem by Dr. Gerald Walker in a recent issue of Scientific American. Biological effects of radiation without heat. The problem became more acute when the results of the Navy's sanguine studies, see Chapter 8, became known. Because the energy in electromagnetic radiation is proportional to the frequency, there was absolutely no way that 45, 60, or 75 hertz could cause any heat effect. Yet the sanguine studies indicated important functional changes in humans. Later, other studies were done at 60 hertz and additional bioeffects were found. By this time, the engineers were certain that the biologists were either very poor scientists or certifiable loons. However, the physicists were not so sure. The work of Dr. Susan Bawin and W. Ross Adey of Loma Linda University was the benchmark in this situation. In 1976, they reported that irradiation of living nerve cells in culture with 16 hertz fields produced a measurable increase in the number of calcium ions coming out of the cells. When other labs tried to duplicate this result, they confirmed that ELF did indeed produce calcium ions efflux, but they reported its occurrence at slightly different frequencies. The resulting argument over whether the efflux was due to chance or whether there was hidden variable that had not been identified generated more heat than light for some time. Enter the resonance concept. In 1982, Dr. A.H. Jafari Asil and his colleagues at University of Salford in England reported that yeast cells displayed both nuclear magnetic resonance and electron paramagnetic resonance, and that these resonances were different depending on whether the cells were alive or dead. They found also that when living yeast cells were exposed to conditions of nuclear magnetic resonance, they multiplied at twice their normal rate. And the daughter cells were half as large as normal. Perhaps a more complex type of resonance was part of the answer after all. The advantage of complex resonance, such as nuclear magnetic resonance, is that the energy in the field is concentrated upon single physical entities, such as the nuclei of certain atoms, rather than being spread among all the cells of the body. In 1985, Dr. Carl Blackman of the EPA and Dr. Abraham Liboff of Oakland University, working independently, integrated the reports of Jafari Asil and the attempts to duplicate Baldwin and Adie's experiments. They concluded that the strengths of the local steady state magnetic field of the Earth and at the site of each of the laboratories was hidden variable that determined the different frequencies reported. Both Blackman and Liboff suggested that the mechanisms involved was a specific type of resonance, cyclotron resonance, which has nothing to do with cyclotron, an early type of particle accelerator used in atomic physics. When they applied the mathematical equations to cyclotron resonance to the different frequencies reported by different laboratories, along with the respective strengths of the local magnetic fields, they found the same result. A footnote. Nuclear magnetic resonance is now a familiar diagnostic tool in medicine known as magnetic resonance imaging, or MRI. It is one group of complex resonance phenomena based upon the relationship between a constant magnetic field and a time-varying or oscillating electric or electromagnetic field, affecting the motion of charged particles, such as ions, charged molecules, atomic nuclei, or electrons in the body. End footnote. The calcium efflux was the result of cyclotron resonance between the frequency of the applied electric field and the strength of the Earth's local magnetic field at each separate laboratory. Cyclotron resonance can be explained as follows, albeit in a somewhat simplistic fashion. If a charged particle or ion is exposed to a steady magnetic field in space, it will begin to go into a circular or orbital motion at right angles to the applied magnetic field. The speed at which it orbits will be determined by the ratio between the charge and the mass of the particle and by the strength of the magnetic field. We know the frequency of rotation, the number of times per second that the particle completes a full rotation, from the equation relating the charge and mass ratio of particle and the strength of the magnetic field. If an electric field is added that oscillates at exactly this frequency at right angles to the magnetic field, energy is transferred from the electric field to the charged particle. If the direction of the electric field is slightly off from the right angle, the particle will move in a spiral pathway. We can substitute an oscillating magnetic field for the electric field and still obtain cyclotron resonance. However, it must be applied parallel to the constant magnetic field. Cyclotron resonance may be produced anytime there is a steady magnetic field combined with an oscillating electric or magnetic field acting on a charged particle. Many of the activities of living cells involve charged particles, such as the common ions of sodium, calcium, and potassium, acting on passing through the cell membrane. Cyclotron resonance has the ability to transfer energy to these ions and to cause them to move more rapidly. These effects will change the function of living cells by enabling the ions to pass through the cell membranes more effectively or in greater numbers. Cyclotron resonance is a mechanism of action that enables very low strength electromagnetic fields acting in concert with the Earth's geomagnetic field to produce major biological effects by concentrating the energy in the applied field upon the specific particles, such as the biologically important ions of sodium, calcium, potassium, and lithium. The equation for cyclotron resonance says that as the strength of the steady state magnetic field decreases, the energy of the oscillating electric or magnetic field needed to produce resonance also decreases. This is particularly significant when the average strength of the Earth's magnetic field between 0.2 and 0.6 Gauss is put into the equation. The frequencies for the oscillating fields that are needed to produce resonance with the biologically important ions turn out to be in the ELF region. The ELF frequencies 0 to 100 Hertz become the most significant part of our electromagnetic environment. The apparent ability of the body to demodulate all higher frequencies, including microwave, substantiates this. Cyclotron resonance provides us an understandable and valid mechanism of action for biological effects of both normal and abnormal electromagnetic fields. Doctors John Thomas, John Scott, and Abraham Liboff, working at the U.S. Naval Medical Research Center, Bethesda, Maryland, first tested this theory using rats and were exposed to a field producing resonance with the lithium ion. They chose lithium because it is naturally present in the brain in very small amounts. It has a calming effect and is used as medication for the manic phase of manic depressive psychosis. Thomas and his colleagues predicted that the cyclotron resonance effect on the normally present lithium ions would increase their energy level, producing an effect equivalent to a medicinal dose of lithium. The exposed rats show depressed behavior as compared to the control rats. Because the study was supported by the New York State Power Lines Project, the researchers used an oscillating magnetic field at the power line frequency of 60 Hertz and controlled magnetic field of 0.2 Gauss, the low end of the Earth's average field. This combination is resonant with the lithium ion. The rats in the resonant field exhibited much less activity and were more passive and submissive than the non-exposed controls, a result equivalent to the result that would be obtained if the animals were given large doses of lithium. Since then, more extensive studies have been done, all of which have supported the cyclotron resonance theory. This theory has been extended in ways too complex to be discussed here. While some criticism have been raised, these have concerned minor points and do not diminish the great value of the entire concept. This is not to say that other types of complex resonance, such as nuclear magnetic and electron paramagnetic resonance, do not have equally important biological effects. They probably do. They just have not been so well studied at this time. The importance of the entire resonance theory cannot be overemphasized. It provides logical mechanisms whereby single cells and specific organs, such as the pineal gland, may intercept and derive information from electromagnetic fields. The theory also appears to be applicable to the basic relationship between living things and the Earth's normal electromagnetic environment. In 1984, I proposed that resonance between the Earth's natural steady state field and the micropulsation frequencies might provide the timing mechanism for cell division. Since the resonance theory is based on frequency and not power, it permits effects from vanishing small fields, such as that observed in 1978 by Dr. U. Akasova at the Crimean Medical Institute in the USSR. The sun's magnetic field is organized into sectors, much like the segments of an orange. Alternate sectors have their fields directed inward and outward, so that as the sun rotates, a slight change is produced as each sector boundary crosses the line connecting the sun with the earth. Akashova observed a rhythm in the multiplication rate of bacteria in culture that coincided with the passage of each solar sector boundary. An incredibly minute alteration of the field at the surface of the Earth. Biological resonance and how it works. The electromagnetic resonance concept may provide an intriguing link to a number of little understood and disputed phenomena, such as an extrasensory perception and the ability of healers to diagnose and treat patients. In both of these activities, the participants may be consciously using an innate biological mechanism similar to that of magnetic resonance imaging. MRI depends upon the same principles as cyclotron resonance. The latter requires both a steady state magnetic field and an oscillating electrical field acting on a charged molecule or atom. Nuclear magnetic resonance is quite similar, except that the nucleus of an atom is resonated. The magnetic imagers in use today resonate the nuclei of hydrogen atoms in the body. The two fields combined transfer energy into the hydrogen nuclei. The image is formed by producing the resonance, exciting the hydrogen nucleus, and then stopping the oscillating field. The nucleus immediately returns to its unexcited state, giving back the energy as the electromagnetic signal that is sensed by the imager. In theory, all types of complex resonance may be used in the same way. The resonance state is produced when the right combination of fields transfer energy to a certain component of the body. The fields are then shifted out of resonance, and the excited component releases energy as the electromagnetic field that is sensed by appropriate devices. The clinical use of nuclear magnetic imaging, this process is repeated many times. The return signal is stored in a computer, which gradually builds up a three-dimensional image of the interior of the body. Different organs are seen on the basis of their water content and the state of their hydrogen atoms. Hydrogen nuclei in cancer tissues have a different signal than those in normal tissues, and they return a different signal. Clinical magnetic scanners use very strong magnetic fields and correspondingly high radio frequency fields as the oscillator. This is done to produce a high resolution image with great detail. While lower field strengths and lower frequencies would also work in imaging, they would yield little detail. Magnetic resonance and the healer phenomenon. Evidence that healers can diagnose the site of a disease process by giving off some type of electromagnetic field from their hands was presented in Chapter 4. I have theorized that the field given off by the healer induces electromagnetic resonance of some body component, and that the healer senses the return signal. The healer gradually builds up an image in his or her mind that is similar to that of the magnetic imager, but has lower resolution. The theory does not require that the hydrogen ion be the target particle. It could be at any one of a number of biologically significant ions, or it could be a specific molecule, such as an enzyme or a peptide. For the healer to be able to diagnose the site of a pathology, the signal that is returned to the healer's hand from pathological tissue must be different from the signal of the same tissue when normal. Such a difference could be produced by a deviation from the normal amount of target ions or particles present, or by an abnormal electronic state of the same target ions or particles. It may be possible to explain the therapeutic effect produced by healers on a similar basis. If verified, this could lead to the development of specific clinically useful devices. We should not only think of influencing specific ions within an area of pathology, but we should also consider some resonant action between the fields given off by the healer and the intrinsic electrical control systems within the body. While these currents have a vanishingly small flow, they would nevertheless produce local DC magnetic fields within the tissues. These fields, in combination with the frequency field given off by the healer, could result in resonance with other charged particles. Because this theory rests on a complex resonance, the Earth's steady magnetic field must be involved. The oscillating field from the healer should then be in appropriate ELF range. Because the strength of the Earth's field varies on a diurnal cycle, the resonant frequency range should also vary slightly, and healers' emitted frequency should shift accordingly. However, it would appear unrealistic to expect a healer to perform with the precision and capability of a frequency generator. Therefore, a range of frequencies possible from a healer is probably limited to that required by the natural variations in the Earth's steady state field. If this theory is correct, healers should be able to work with greater precision and display greater diagnostic and healing abilities during times of quiet geomagnetic field conditions. Conversely, they should be adversely affected by periods of magnetic storms and perhaps by locations in which man-made, high-strength, steady magnetic fields or competing ELF fields are present. None of these possibilities have yet been explored in relation to the healer phenomenon, magnetic resonance, and extrasensory perception. All of our radio communication systems rest on resonance phenomena, albeit the simple wavelength type. When we tune a radio receiver, we are simply changing the frequency at which the internal circuits resonate, and we receive only that signal in which we are interested. This system is not highly sensitive to magnetic fields except during magnetic storms, which change the characteristics of the ionosphere and either interfere with reception or specific frequencies or enable us to detect signals from much greater distances than normal. The phenomenon of extrasensory perception, ESP, has been likened to the biological radio, with the sender giving off an electromagnetic signal that is sensed in some fashion by the receiver. However, application of radio technology to explain this phenomenon has not been successful. It is difficult to explain the distances of transmission when the measurable fields given off from the human brain are almost imperceptible and when the tuned circuits for the transmitter and receiver have not been identified. However, we now know that ESP of a variety of types is enhanced by a quiet geomagnetic field and adversely affected by a disturbed field. This finding was presented at the session on parapsychology at the annual meeting of the American Psychological Society in 1986 by Drs. Michael Persinger, Marcia Adams, Erlander Haraldson, and Stanley Krippner. Each had worked independently of the others and had used different techniques. Nevertheless, all had arrived at the same conclusion. The phenomenon of extrasensory perception is interfered with by a disturbed geomagnetic field. This connection could indicate that a complex resonance phenomenon is involved, with the geomagnetic field serving as the steady component. The exquisite sensitivity of the resonance process certainly would assist in dispelling, to some extent, the problem of transmitting and receiving the extremely low power signals that must be involved. However, the data may also be interpreted in other ways. The phenomenon of ESP requires components similar to radio communication systems, a transmitter, a signal that spans distance, and a receiver. If magnetic forces are involved in this process, a disturbed geomagnetic field could interfere with the ability of the transmitter or receiver to operate, or with a propagation of the signal itself across distance. The apparent ability of the signal to span long distances is a problem if simple radio technology alone is considered. However, ELF signals are known to be transmitted in the magnetic ducts over long distances. This transmission is in fact associated with the increase in signal strength. Magnetic ducts are formed by adjacent lines of the magnetic field extending from the north to south magnetic poles. The problem is that this can be used to explain only north-south transmissions of ELF signals. We continue to discover new aspects of the Earth's magnetic field, however, and it would be would appear reasonable to keep these possibilities in mind. Resonance theory provides us with clues about the types of experiments that could yield some understanding of the mechanisms involved. The most pressing problem of ESP in its lack of reproducibility. On occasion, it works with astonishing precision, while at other times it simply cannot be replicated. In science, this is cause for rejection of the entire concept. If something cannot be replicated in a laboratory, it doesn't exist. Knowing the potential relationship of ESP to the status of the Earth's magnetic field might enable us to remove this lack of reproducibility by disclosing the hidden variable. Furthermore, it would permit us to design experiments to explore this relationship in detail. Magnetic fields and cell division. If the cellular events in mitosis are magnetically active and are dependent upon the resonance effect of the Earth's natural or normal fields, then the presence of man-made abnormal fields could lead to disturbances in mitosis or to genetic abnormalities. The evidence is clear that all cells in the process of active cell division are directly affected by the exposure to both ELF and microwaves. Unfortunately, our knowledge of physics involved in this process of mitosis is minimal, and the experiments of the effects of field exposure on cell division have been limited to simply observing changes in the rate at which it proceeds or in the production of abnormal chromosomes. However, one intriguing observation was made in 1980 by Dr. David Cohen of the National Magnet Laboratory at MIT. Dr. Cohen reported that the squid magnometer detected a steady magnetic field from the human hair follicles. The cells of the hair follicles are constantly in mitosis. But Cohen did not check on the possibility that mitosis was producing the magnetic signal. As a result, several different experiments that could have evaluated this possibility have not been done. Because no one yet has done the simple experiment of directly observing the process of mitosis through a microscope while the cell is exposed to an external magnetic field. At present, we can only speculate about what would be seen. We obviously need to pry much more deeply into this important relationship. If one watches cells through a microscope, the process of cell division appears lengthy, averaging about 24 hours. During most of this time, the cell is engaged in doubling its amount of DNA so that there is enough to make 2 new cells. Dr. Abraham Liboff was the first to discover that the process can be speeded up by exposing the cells to ELF magnetic fields. The actual process of cell division is a complex event that takes only a few minutes to complete. Mitosis is the final stage of the cycle and is the only stage that can be seen under a microscope. The same process occurs in cells in both the body and in culture. Using special techniques, it is possible to synchronize this process in all or most of the cells in a culture so that they go into mitosis roughly simultaneously. One can also stop the process at stage at which the chromosomes are just beginning to pull apart. This technique is used to count and characterize the individual chromosomes and sometimes to reveal abnormalities at first report by Heller. Dr. Martin Peony of the University of California, Berkeley has recently shown that major changes occur in the calcium ions within the cell during the anaphase stage of mitosis. Conceivably, the field exposure may interfere with the process via a cyclotron resonance effect. It is also possible that some of the complex structures formed during mitosis may have magnetic properties of their own. All substances are magnetic to some extent because the spin of electrons around the nucleus of any atom is equivalent to a tiny electrical current and will produce a corresponding magnetic field. Magnetic substances may be ferromagnetic, producing a magnetic field on their own. Paramagnetic, lining up a parallel to the field lines of an external magnetic field, or diamagnetic, turning to a right angle to the field lines an external magnetic field. These different types of magnetic materials were discovered by Michael Faraday in the late 1800s. Faraday exposed many different substances to non-uniform or inhomogeneous magnetic fields in which the field lines are not parallel to one another. The exact classification depends upon the atomic composition and structure of the materials, and the actual situation is much more complex than that presented here. Nevertheless, this simplistic classification indicates the complexity of the magnetic properties of matter. If it is somewhat absurd to consider chromosomal effects from L fields, it is totally absurd to postulate that DC fields could have any such effect. As a result, the majority of scientists in this area have avoided studying DC field effects. However, while searching the literature in the 1960s, I found several earlier reports of DC magnetic field effects associated with cell division. In 1938, Dr. C.G. Kimball reported that inhomogeneous DC fields of only a few Gauss could produce statistically significant decreases in the growth rates of yeast cells. Kimball also reported that homogeneous fields with strengths as high as 11,000 Gauss did not change the normal growth rates of these cells. Therefore, the effect had to be due to inhomogeneous field itself. In 1978, I experimented with the effects of DC electrical fields, also called electrostatic fields, on growing cancer cells. We implanted cancer cells into mice and then exposed the mice to an inhomogeneous DC field for several weeks. We set up two different conditions. One group of animals was exposed to a field that was horizontal, parallel to the ground, and the other was exposed to a vertical field at right angles to the ground. To our surprise, we found a major difference between the two conditions. Chromosomes of the cancer cells in the animals exposed to the horizontal field were markedly abnormal, while those in the animals in the vertical field group were totally unchanged from their usual pattern. In the horizontal field group, we found chromosome breaks, exchanges of portions of chromosomes from one to another, formations of ring-shaped chromosomes, and tiny fragments that had broken off from the other chromosomes. The production of such severe chromosomal abnormalities usually results in an inability of the cells to divide and ultimately leads to either their death or to the production of a new line of mutant cells. We investigated these possibilities and found that the cancer cells with the marketed chromosomal abnormalities died because they were unable to replicate. There were obvious clinical implications from the study, but we were unable to follow up on it, and the experiment was never repeated. It appears that the exposure of a dividing cell to an inhomogeneous DC magnetic field causes a physical force to be exerted on the chromosomes or on one of the other macroscopic structures as associated with mitosis, resulting in structural abnormalities in the chromosomes. Complex electronic resonance effects operated at the level of individual ions in molecules and can occur even in the absence of cells. The effect at the cellular level is dependent upon the organization and the specific type of cell within which the field effects are produced. We have just begun to explore the effects of fields on cells from the viewpoints. While the effects of complex electronic resonance phenomena at the level of ions and molecules may be significant, the resultant change in the function of structures of the cell may be far more important. The effects of the field exposure at the level of the total organism will be the sum of the effects at the molecular level, the cellular level, and the level of the specific organs designed to be sensitive to the Earth's normal electromagnetic field environment. Field effects on entire functioning organisms are, therefore, a cascade of changes that finally result in many different structural, functional, and behavioral alterations, such as the new diseases that are emerging today. These are the subject of the next chapter. The data obtained in the past few years indicate very clearly that we must now include the Earth's normal geomagnetic field as an environmental variable of great consequence when we deal with the basic functions of living things. In my opinion, this knowledge is probably the single most important discovery of the century. It provides us with a key to the mechanisms by which all electromagnetic fields produce biological effects, and it may enable us to determine more accurately the risk involved in our technological use of such fields. More importantly, it opens the door to a greater understanding of life processes, similar to that which was opened by William Gilbert in 1600 when he began the scientific revolution. The subsequent discoveries of the 17th and 18th centuries gave us our present world. The new discoveries that are linking us to the Earth's magnetic field can give us yet another world if we explore them properly.